Most developers run one AI coding assistant at a time. You give it a task, you wait, you review, you move on. That's the bottleneck nobody talks about. What if you could run 30 of them simultaneously, each on a different task, each in its own isolated environment, all coordinated from a single terminal window? That's exactly what Swarm does. Swarm is an open source tool built for Linux that lets you spin up and manage a fleet of coding agents in parallel. Not two or three, dozens. Each agent gets its own workspace, its own Git branch, its own task. You orchestrate all of them from one place. When they finish, you review the diffs and decide what to merge. The human is still in the loop, but the throughput is completely different. Here's what the actual workflow looks like. You define a list of tasks. Could be bug fixes, could be feature implementations, could be refactoring jobs. Swarm spins up an agent for each one. On Linux, it uses process isolation to keep each agent sandboxed. They all run concurrently. While Agent 7 is wrestling with a database migration, Agent 12 is already writing unit test stalker for a completely different module. You're not waiting for one to finish before the next starts. The output is a set of branches. Each agent commits its work to its own branch. You pull them up, review the diffs, and merge the ones that pass. It's closer to managing a team of junior developers than using a single copilot. The mental model shift is real. But here's the thing. Swarm is not magic. And being honest about that matters. First, the agents are only as good as the underlying model you're pointing them at. Swarm is the orchestration layer. If your model produces mediocre code, Swarm gives you mediocre code at scale. Garbage in parallel. Second, parallel doesn't mean coordinated. These agents don't talk to each other. Agent 3 doesn't know what Agent 9 is doing. If two agents are working on overlapping parts of the codebase, you will get merge conflicts. In some cases, serious ones. The tool assumes you've designed your task list to minimize overlap. That's your job, not Swarm's. Third, resource consumption is real. Running 20 agents simultaneously on a single machine means 20 processes hitting your CPU, your RAM, and your disk. Depending on how resource hungry your chosen model is, especially if you're running local models, you will hit hardware limits fast. What surprised me was how quickly a 16-core machine starts sweating with 10 agents running heavy inference locally. If you're deploying this seriously, you're looking at cloud infrastructure. DigitalOcean's GPU droplets are actually a reasonable fit here. You get per hour billing and Linux native environments, which is exactly what Swarm expects. Fourth, this is not a polished product. It's a show HN project. The documentation is sparse, error messages are minimal. If an agent silently fails, you need to know how to read a process log to figure out why. This is a tool for engineers who are comfortable in the terminal and don't need guardrails. So where does this actually go from here? The honest answer is that the interesting potential is in integration, not isolation. Right now, Swarm is standalone, but imagine hooking it into a CI pipeline. A pull request comes in, it triggers a swarm of agents. One reviews for security issues, one checks test coverage, one suggests refactors, all in parallel. The reviewer sees a consolidated report. That's not science fiction. That's a weekend integration project for someone motivated. Another realistic direction, task decomposition. Today, you write the task list manually. A natural next step is an upstream agent that reads a large ticket or a product spec and breaks it into parallelizable subtasks automatically, then hands those to the swarm. That closes the loop considerably. The third direction is smarter merge arbitration. Right now, resolving conflicts between branches is your problem. A thin arbitration layer that detects conflicting changes and flags them, or even attempts automated resolution on low-risk conflicts, would make Swarm dramatically more usable at scale. None of this requires reinventing the project. It's all additive. Now, why does this exist? Because the standard assumption in AI-assisted development is sequential. One chat window, one task at a time. That assumption is inherited from how we used to work, not from any technical constraint. The actual bottleneck in software development was never typing speed. It was thinking time and review time. If an AI can handle the implementation, the real question becomes, how many implementations can a single engineer review per hour? That number is higher than one. Swarm is a bet that the correct mental model for AI-assisted development is closer to engineering management than pair programming. You define the work, you distribute it, you review the output. The agents are the implementers. That's a fundamentally different way of working, and it's starting to look like the right one. If you want to go deeper, the repo is linked below. It runs on Linux. Setup is straightforward if you're comfortable with the command line. Next episode, we're looking at a tool that does something similar but for data pipelines. Autonomous agents that clean, transform, and validate data in parallel. If that's in your world, subscribe and you won't miss it.